All right, this is section 2.3, subtracting rational numbers. And before we get into the rational numbers part, which is the fractions and decimals, let's review how to subtract integers. Now remember, when you subtract integers, you want to add the opposite of the second number. So we leave the first number alone. We change the subtraction symbol to addition, so we're adding. The opposite of the second number would make this a negative 20. So we can think of it, instead of 12 minus 20, we can think of it as 12 plus negative 20. These numbers have different signs, so we're going to subtract. Keep the sign of the larger number, then we'll be exact. So that's actually negative 8. For example B, we can rewrite that as negative 6, and then we're going to change it to plus, and we're going to take the opposite of 15, which is negative 15. And we have same signs, so we're going to keep the sign and add to get negative 21. In example C, we have negative 18 minus negative 9, which is the same as negative 18 plus positive 9. And when you rewrite it this way, we have different signs, subtract, keep the sign of the larger number, then we'll be exact. Example D, we can rewrite that as negative 16 plus positive 6. Different signs, subtract. Our answer is actually just going to be 0. We don't have a larger number. That's because they are the same. 16 minus 16 is 0. Example E, we can rewrite this as negative 13 plus negative 17. Same signs, keep the sign and add. 13 and 17, let's see, is going to give us 30. So negative 30 would be our answer. And then for example F, we can rewrite this as negative 12. We're going to keep the first number. We're going to rewrite it as addition, and we're going to change the second number, take the opposite so that it is positive 30. We have different signs, so we're going to subtract. And when you subtract, you're going to get 18. And we're going to keep the sign of the larger number, which is positive, so positive 18. So that's how we subtract integers, and we're going to do these exact same rules with our rational numbers, our fractions and decimals. We just have to add more to it. We have to, with fractions, find common denominators, and decimals, line up the decimal points. So remember, to subtract numbers, you are adding the opposite of the second number, and just the second number. We never change the first number. All right, so let's start with decimals. When we are subtracting decimals, we want to rewrite it as addition. We want to check to see if it's same signs or different signs. We want to line up the decimal points, putting the larger number on top, and then we're going to add or subtract depending on whether we have same signs. If we had same signs, we would add. And if we have different signs, we would subtract. So these are the same rules that we used for adding decimals, except with the one additional step of rewriting it as an addition problem first. All right, so for this first one, we're going to subtract these decimals. The first thing we're going to do is rewrite it as an addition problem. And I'm okay if you just go ahead and mark that as a plus sign instead of a minus sign. We're going to change it to adding. But if we're going to do that, we have to take the opposite of the second number, and now it becomes negative. So then when I check here, I've got same signs. We're going to keep the sign and keep it. I might even mark it that I know it's supposed to be negative, and we're going to add. So we're going to add. We're going to put the larger number on top. 12.63 is our larger number. Then we're going to put 5.627 on bottom, and we're adding because they have same signs, which means I can add an extra 0 in here. 0 plus 7 is 7. 3 and 2 makes 5. 6 and 6 makes 12. Drop down the decimal point. 1, 2, and 5 makes 8, and 1 and nothing makes 1. So we have negative 18.257. So just like last time, we're lining up the decimal points. And then we're just adding these. Even though the problem was a subtraction problem, when we rewrite it, we have same signs, so we're adding. In example B, 4.5 minus 8.91, you're probably thinking, well, there's no negatives, but we are taking away a number, 8.91, that is bigger than 4.5, so we have a problem here. So it is going to be helpful to go ahead and rewrite this as an addition problem by changing that to a plus, but then also taking the opposite of the second number. So now we have different signs. We know we have to subtract. We must put the larger number on top when we're subtracting. I think it's good to just go ahead and put the larger number on top every time so we don't forget it. So 8.91, different signs, subtract 4.5. Line up those decimals. You can put an extra 0. And then we're going to subtract. 1 minus 0 is 1. 9 minus 5 is 4. 8 minus 4 is 4. And we're going to keep the sign of the larger number. Our larger number, as you can see, is the negative number that's now negative. So we have more negatives than we have positives. So our answer is going to be negative 4.41. All right, in example C, we're going to change this to an addition problem, and we're going to take the opposite of the second number, which means it's now going to be positive. So this is just 72 plus 5.14. So put the larger number on top. Now, it doesn't have a decimal point, so we know it comes at the end. And then 5.14, so we can put some extra zeros in here. And then we're going to add, because they have the same signs. 4, 1, 2, and 5 makes 7. 7, nothing makes 7. So we have positive 77.14, or 77 and 1400ths as our answer. And one more decimal problem here, negative 0.6 minus negative 17 can be rewritten as negative 0.6 plus positive 17. They have different signs, so we're going to subtract, and our larger number is definitely 17. The decimal point, again, comes at the end. And we're going to subtract 0.6. So I've got some extra zeros that I need to add here. You can even put one there if you want to. And we cannot do 7 or 0 minus 6. We're going to borrow from the 7, make it a 10. 10 minus 6 is 4. Drop down the decimal point. 6 minus 0 is 6. 1 minus nothing is 1. Keep the sign of the larger number. Well, we clearly have more positives than we do negatives. So our answer is going to be positive 16.4. So again, that's decimals, and that's just, again, lining up the decimal point and then checking your signs after you change it to an addition problem. Check your signs to see if you're really adding or if you're subtracting. All right, so fractions. Again, these are the same rules that we used for adding fractions, except with the one extra rule that we have here, which is rewrite any subtraction problem as an addition problem before you do it. We still have to find a common denominator, specifically the least common denominator, so you don't have to reduce as much, if at all. We're going to change the numerators. If we end up changing the denominator of a fraction, we have to change the numerator. And then we're going to ask, okay, same signs or different signs? We're going to add or subtract. Again, same signs would mean that we're adding. And different signs would mean that we are subtracting. And then, of course, reduce. That's something you have to do with fractions. So that's a lot of steps, and I didn't even include the step of changing mixed numbers into improper fractions. Now, you don't have to change all mixed numbers and improper fractions, but most of you have probably learned that that you need to do that. So that's just another step. So there's a lot of steps, and then that's okay. We're still going to go one step at a time through these problems. All right, let's start with this first one, 2/5 minus 7/15. Number one is to rewrite it as an addition problem. So we're going to change the subtraction sign to a plus sign. We're going to take the opposite of the second number. We're going to make it negative, and I'm just going to put that negative up there with a 7, because remember, that's really what I look at as the numerators. And then I'm going to find a common denominator. My least common denominator is 15, because I can just take 5 times 3. And 2 times 3 then. If I'm going to change the denominator, I have to change the numerator. And that's going to give me 6/15 plus negative 7/15. So we check our signs. They're different, right? We're just looking at our numerators here. And our numerators have different signs, so we're going to subtract. 7 minus 6 is 1. Keep the sign of the larger number. And that's going to make it negative 1 over 15. All right, on example B, negative 5 3/8 minus 2 1/3 can be rewritten as negative 5 3/8 plus negative 2 1/3, which means we have same signs. We're going to keep the sign and add. So it is going to end up being negative. You may want to make note of that. And then we are going to change these into improper fractions. 8 times 5 is 40, plus 3 is 43. And don't forget it was negative. So negative 43/8 plus 3 times 2 is 6, plus 1 is 7, and that was also negative now that we changed the sign of it, so negative 7/3. Our least common denominator is going to be 24. That's the first multiple of 3 that also is a multiple of 8. So I'm going to times the first fraction by 3. 43 times 3 is, let's see, 43 times 3, 9 and 12, so 129, and it's negative, plus 3 times 8 is 24, and 7 times 8 is 56, and it's also negative. And we have same signs again, so we're keeping the sign. And we're going to add. So 129 plus 56, make that a 9. Okay, 9 and 6 makes 15. And that's 8 and 1, so negative 185 over 24. Then we have to check to see if it reduces. Now, I know that 24 is divisible by 3, and an easy way to check to see if a number is divisible by 3 is to add up each of the digits in that number. So 1 plus 8 is 9, plus 5 is 14. Now, since 3 does not go into 14, 3 won't go into 185, so we know it is not divisible by 3. We also know it's not even, so 2 doesn't go into 185, even though 2 would go into 24. So that fraction does not reduce. If you wanted to write it as a mixed number, which you do not have to do, then you would see how many times 24 goes into 185. It goes in 7 times, so that becomes our mixed number. And then 7 times 24 is 168. And that means that we have 17 left over. And you can see why I would probably just prefer you write it as a improper fraction. You don't need to write it as a mixed number. Now, that's one way you could do that. Another way you could do this problem is to keep them as mixed numbers. So if you keep them as mixed numbers, you would still need to have a common denominator, which is still going to be 24. We're still rewriting as an addition problem, making this number negative now. And the denominator is going to be 24. And then we are timesing 8 by 3. So 3 times 3 is 9. And we're timesing 3 by 8. And 1 times 8 is 8. We have same signs, so we're keeping the sign and adding. Start with your fraction parts. 9 24ths plus 8 24ths is 17 24ths. And then start with your whole number parts. Negative 5 and negative 2 makes negative 7, which, remember, was the exact same answer we got when we did it earlier with the improper fractions. We got negative 7 and 17 24ths right here. So it's the same exact answer with a lot less work. Now, not every problem is that easy to do, leaving as mixed numbers, and some people find it confusing. So if that's you, then I would suggest just stick with your improper fractions. But again, sometimes leaving them as mixed numbers can make the numbers smaller, easier to do in your head. We don't have to do a bunch of side work like this, and some people find it quicker. Our example C here, 4 minus negative 6 3/4 can be rewritten as 4 plus positive 6 3/4. Now, this one I could write as improper fractions, but I think you're going to find this really easy. If I had 6 3/4 and I added 4 to it, let me show you what this looks like. 6 3/4. Again, I'm adding 4 to it. I don't have any fourths over here with the 4. So I just add my fraction parts together. There isn't a fraction part over here, so it's just 0, so 3/4. And then I add my whole number parts together. That is super easy. So 10 3/4. If you would have tried to turn them into improper fractions, find a common denominator, and then reduce, you would have still gotten 10 3/4, or maybe you would have gotten 43 over 4, because it's the same answer. But I think just leaving them as mixed numbers was really simple for this one. But not everybody understands that, so I'll do this one with improper fractions. I'm still going to rewrite it as an addition problem. I'm leaving the first number alone, writing it as an addition, and taking the opposite of the second number. So they have same signs. I'm going to keep the sign, which is negative. I'm going to add them. So I've got 8 times 2, which is 16, plus 3, which is 19/8, and it's negative, plus 6 times 4, which is 24, plus 1, which is 25, and it's also negative, and that's over 6. My least common denominator is not going to be 48. There's a smaller one, and it's by timesing by 4 and timesing by 3. You'll get 24 for both of them. So 19 times 3 is, let's see, 7 to 57, so negative 57. Don't forget that that was negative over 24, plus 24 again for the bottom, 6 times 4, and 25 times 4. If you have 4 quarters, that's just $100, a dollar. So that's going to be negative 100. They have same signs, so we're going to keep the sign, keep it again, like we said we would, and we're going to add, and that's going to make negative 157 over 24. We're going to check very quickly to see if we can reduce this. If you add the digits, if you add the digits up of the first number, you get 1 and 5, which makes 6, and plus 7 makes 13. 3 does not go into 13, so 3 will not go into 157, even though it goes into 24. Also, this number is not even, so 2 won't go in. That's a good sign that this thing will not reduce for us. So our answer is negative 157 over 24. I'm not even going to bother turning that into to a mixed number because I've already done so much work for this problem. All right, you're going to have a couple problems in your homework that ask you to find the distance between two numbers, or this one that says how far apart is negative 12.31 and negative 7.97. And just so you know, since we're in a subtracting section, that does mean that we're going to subtract. Okay, if anytime you want to find the distance between two numbers, you subtract. Like if I said, hey, how far apart are 10 and 15? You'd say they're 5 apart. And how do you know? Well, 15 minus 10 is 5. So that's how you find the distance. And notice that when you subtract, you always put the larger number on top. So if you're looking at these two numbers here, the negative 12.31 and the negative 7.97, we're going to subtract them, and we're going to write the larger number first so we can put it on top. Now, if you're thinking that 12.31 is the larger number, it would be if it were positive. But since both these numbers are negative, negative 12.31 is more negative, which makes it smaller. So this one is actually our larger number. So we're going to write negative 7.97 minus negative 12.31. We are subtracting them because we want to find the distance between them, that's what you do. Even though it looks kind of weird, you're like, how am I going to find the distance? Well, subtract them and you'll see how far apart they are. Now, realistically, before we even start this problem, negative 7, and negative 12 are like 5 apart. So my answer should be something close to being 5 apart. And remember, since distance is always positive, it doesn't make sense for me to say they're negative 5 apart. They're 5 apart. It's the absolute value. Distance is always positive. So when I do this, I should get a positive answer. Now, if you rewrite it as an addition problem, you will get a positive answer because we're going to subtract, right, the larger number on top, which is now the positive one, right? We got to put the 12.31 on top when we subtract. And then I've got more positives, so my answer is going to be positive. And we're going to go ahead and subtract. Now, I already lined up the decimal points, but we have to borrow from the 3 to make it a 2. And this 11 minus 7 is 4. And I have to borrow again. And 12 minus 9 is 3. And I have to borrow again. And 11 minus 7 is 4, and it's going to be positive 4.34. That's how far they are apart. Remember, we said it was going to be kind of close to 5, so that's pretty darn close.